Welcome everybody to this webinar. Please first make sure that you have turned off your cameras and muted your microphones, please. My name is Anna Sirokov. I work for Finnish Transport and Communications Agency in Finland as Chief Advisor on ITS, and I will moderate this webinar. It's really my pleasure to have all of you here. This morning I heard first that we have registered participants from 28 countries, altogether 160 people. Hoping that most of the registered ones could also be able to join this webinar today. In EUEIP, we have had a tradition to have a ITS forum seminar once a year. We used to have it as physical seminar, but this year, because of the corona situation, we are having this as web seminar. Now, of this event, this one is the third webinar we are having. In January, we will also have a fourth one. The topic of this webinar is perspectives and contribution of road operators for facilitating automated driving. For those ones, as we have many people here not participating in EUEIP, not even from Europe, I can say some words what EUEIP is. It stands for European ITS Platform. It was is an EU-funded or co-funded project we started already 4 years ago. It was supposed to end this December, but it has been extended by 1 year. In this project, national ministries, road authorities, road operators and partners from private and public sectors cooperate together to foster, accelerate and optimize the current and future ITS deployments in Europe in a harmonized way. We have several activities in this EUEIP which deal with evaluation of services, developing guidelines, discussing CITS principles, developing national access points, discussing and understanding what quality of services means. But today we are dealing with the activity doing with automated driving. Today's agenda, after my opening, we will have an introduction speech by Geert van der Linden from the European Commission. After that, we have 4 presentations which cover the main topics we have been working for 4 years. We have Ludovic Simon, who talks about requirements of highly automated driving to road operators. We have Magnus Hjelmdahl, who talks about best costs and benefits of highly automated driving. Then Martin Ameling, who presents our roadmap work. And then last, Mihai Niculescu, who talks about automation of road operators' own ITS. Some housekeeping rules. I wish that all of you keep your cameras turned off and microphones muted unless you are speaking. We have our presentations approximately 10 minutes long, and after each presentation we have reserved 5 minutes time for questions and comments. You can see a chat box on your screen and you can give your questions and comments there. You can also, so you can either present your questions there and I can see them and read them out, or you can ask or request for a moment for yourself to present the questions. This webinar will be recorded and it can be seen at EUEIP's websites also afterwards. Now, I'm just a bit, when I found my perfect screen on my... Yep. Excuse me. Now Gert van Linden will give his opening. Mr. Gert van Linden has been working in the Smart and Sustainable Transport Unit of DT Move for over 5 years. He started when the CITS platform was still active, and currently he coordinates all the work surrounding cooperative, connected and automated mobility, called CCAM. So please, Mr. van der Linden.
Thank you very much, Anna, and welcome. Good morning, everybody. I'm very glad to be here and be able to introduce, which I am sure will be a very interesting morning. First of all, I'd like to quickly show an overview slide that some of you may have seen before, because I use it for a long time already. And it just shows where we're coming from. If you go back to 2010, when we started with the ITS directive and we started with the objective to deploy intelligent transport systems, we were still very much thinking in different work streams. So on the one hand, there was the cooperative side with the CITS platform that Anna already mentioned. There was the connectivity side, where we see that everybody is getting increasingly connected. And then, of course, we saw automation, which at the time, and actually still today, is still in the ADAS system, so support for driving, but not actually automated driving. But we see now that in 2020, all these evolutions need to come together, they need to merge, and only when we do that and when everything comes together will we really make progress and enable highly automated driving. And that is why we already last year decided to create a new Commission expert group, so the CCAM platform, which brings together all of the 3 work streams and as well 4 different DGs within the Commission that are active in this field. Now today I would like to focus on 2 of the working groups. So the first one was to develop a European research and innovation agenda for CCAM, and then the working group 3, which was on the physical and the digital road infrastructure, and which obviously has the closest link to the work of EUEIP and this webinar today. So I'll start with working group 3. What we did there is we started listing all the different elements, both physical, digital, and actually even operational elements that could play a role in CCAM. In other words, elements of the infrastructure that can support automated vehicles in delivering new mobility services. We have the bad habit of inventing very long acronyms, so if you remember just one letter, remember the M, because it stands for mobility. That's what we want, that's what we need, better mobility for all our citizens. But we also need to understand what it really means when we say supporting these vehicles. So we started linking all these infrastructure attributes with the actual core driving tasks of an automated vehicle to see whether we can better understand how that support works, which elements are most useful, which are the ones that we should invest in first. Because only when we find such no-regret measures can investments take place. Because today, I think it is still early days. There's a lot of activity going on right now. There are some things that everybody assumes are good ideas, but investments in infrastructure they're very costly. It takes a long time. So we need certainty that we're making the right choices. And finally, we are discussing ISAT levels, which is an equivalent of the SAE levels that exist already for vehicles, to see whether we can define and harmonize different support levels of this infrastructure support. Then if I go back to the first working group of the CCAM platform, this was about the research and innovation agenda, and which has actually led already to the preparations, and I should say very advanced preparations at this stage, for a new EU partnership under Horizon Europe. And I think you may all have seen that we have very good news from Council, So the budget has been approved, which means the Horizon Europe gets the green light, because that was a precondition. And so we are preparing for a new partnership on CCAM, with the goal to deliver, as I said, new user-centric, inclusive, and in most cases shared mobility services. So the focus is not so much on the technology per se, but on how we can make transport more efficient for both citizens and businesses. So I said advanced preparations. In May already, the partnership proposal was published, and still by the end of this year, maybe early next year, we will finalize the memorandum of understanding and the strategic research agenda, so that in Q1 of next year, the partnership can launch alongside the first calls of the work program. I won't go into too much detail, but the strategic research agenda has 7 different clusters, all contributing to making CCAM a reality. And the most important one for today is number 4, because that is about integrating the vehicle into the transport system. So this is where we make the link with the infrastructure, where we make the link with traffic management, where we make the link with a multimodal transport system. At the same time, so far, this partnership is all on the Horizon Europe, so this is research and innovation. But at the same time, we have the Connecting Europe facility, which will continue to support and build the European network. Of course, the EUEIP, the project organizing this webinar today, is one of those initiatives that is supported by the Connecting Europe facility. And we will see in the next years, I have no doubt, that the digital element of infrastructure will become increasingly important. This is, of course, because it will increase the safety of roads, but also the efficiency of traffic. And this is the topic of today, it will prepare us for more connected and more automated vehicles. So, concluding, because I think we all look very much forward to what the other speakers have to say and what we've learned and how much progress we've made. But for me, the conclusions so far are that the CCAM stakeholder community is even wider than it was for intelligent transport systems. And to progress, we need to build both knowledge and consensus, because views are often very similar. We often think we are talking about the same thing, but further alignment and a common language are still very much needed to make progress. So the roadmap that we will see today, but also the business models and the other presentations are very timely, because we are also concluding discussions in Working Group 3. So we're ending a first phase of the CCAM platform. I think that whatever we learn today will have to be taken up and be expanded and built upon by the new EU partnership when it starts next year. Because I think everybody agrees now that it's no longer up for discussion that the infrastructure has a major role to play in making CCAM a reality. But, and I said it before, investment levels are high, and these investments will not happen without a coordinated approach and investment certainty. So we need to efficiently link both the development under Horizon Europe, deployment under the Connecting Europe facility, and connect these instruments. We need to look for no-regret measures. I think particularly on the digital infrastructure, there are possibilities. But we need clear recommendations if we want to trigger EU-wide investments. And a very important aspect of that when we talk about digital is, of course, data and sharing of data. And so increased agreement on sharing of data between all parties, private and public, could also help trigger investments on both sides. And then, and I promise this is my final slide, CCAM is a key investment area for Europe. This supports the objectives of the Euro Green Deal. You will have seen also earlier this week a smart and sustainable mobility strategy, which focuses a lot on digitalization. And in parallel, I think this is also part of a digital sovereignty and a competitiveness agenda. So public investment still very much needed, of course, and EU funds will continue supporting the development and the deployment of both CITS and CCAM. We expect to see deployment beyond CEF. So larger projects on CITS, for example, supported by EIB. We will hope to welcome such projects very soon. On the private investments, we of course see a lot of the OEMs are investing heavily in the technology. How the final business models for CCAM will look like, I don't know. I think we will learn more about this morning, but I think it will depend on the mobility services that we end up developing for end users. That being said, once more, I very much look forward to hearing more from the other speakers, and I thank you for your attention.
Thank you very much for your nice opening. Next, we have our first speaker, Ludovic Simon from France, where Mr. Ludovic Simon works for Cerema, and since 2011 as head of the Unit of Innovation in Transport and Systems. He is responsible for standardization, research and innovation on ITS, as well as cooperative connected and automated vehicles. He acts directly as expert within national and European projects in the fields of standardization on connected and automated vehicles, as well as related infrastructures and road equipment. Please, Ludovic, you're welcome.
Yeah, thank you, Anna. So I will present you first task we made on the project about the requirement of highly automated driving to road operators. So this work takes place under the 4.2 activity. And our main objective was to identify the requirement of the higher level of the automated driving, to define the requirement for the road authority, for road operators, but also towards the road equipments on all the need. But we also focused on the requirement about the safety and the efficiency of the transportation system. You can find the deliverable on the web page of the sub-activity of the project. We have in the document, after of course an introduction, you can see that we made benchmarking works on the basic definition of the level of the automations. We have a state of art of the automated driving system on the automated vehicle at the date of June 2020. We have also made the works about the expectation we could have on the subject, on the tentative of the operational design domain description. I will present you just after. In terms of requirement, we made it in 3 different chapters in order to separate it between the physical, the digital infrastructure, but also the requirement towards the legal and the regulation framework. We had also specific chapters on the national activities to provide deployment of autonomous vehicle, which could give good ideas on this. For the benchmarking, some highlight. We have a good state of art of the automated driving systems, but on the expectation for the automated driving, we have seen at the long terms. We made it by difference by the actors, because there is difference between general publics, the commercial vehicle and fleets, the road networks operators and managers. Everyone has a different meaning on this. For the operational design domain description, as you can see now, we separate the static attribute of the ODD and the dynamic attributes. And with this work, we have some example of what we can do to describe an ODD for automated driving. So it will be too long on this presentation to see you, but refer to the document, and we have a big work on this. For the requirement, we made this requirement on the basis of the collection we made from each countries, but also by the feedback of a national project on the return of the experience. And we include in each requirement the specific requirement towards the network operators. So I will focus on it. Towards the physical infrastructures, we have different types of road. Each road types bring its own set of problems, but it's also its own particularity. For example, in urban, you will have high density, but so it's more complex. But you also will have more equipment, more connectivities. In overroad, you will have less connectivity, but also less density of the road networks. The car manufacturers need a consistency within the networks and between the networks. The automated driving system would be certainly easier to develop if there is the less possible local or national peculiarity to deal. So we need to have some kind of harmonizations. The operators and the manufacturer will need to discuss and to find the optimal strategy to achieve it. We need also for the automated driving quality of existing infrastructures, or either to know the quality of the infrastructures. It could appear the new or upgraded infrastructures, for example, at specific point like the runabouts for the dynamic lane assignment, or the arch shouldering opening for traffic stalls. You have new infrastructure in development. So you need to classify the infrastructure capabilities. It will need to the network operator to make an inventory on the classifications. It could be a great works. And they also need to manage the broadcast of the information on the update of this information towards the vehicles. For the digital infrastructure parts, the connectivity is a support for the automatic driving systems. So you need the communication networks. You need also to have digital maps and adapt of the digital maps, and also an adapt of the systems on it. You need a national single point of access. You need to act on the cloud and back office operations, on the positioning capabilities for the vehicles. In terms of supervisions, the automated driving cannot be passed over. They need the supervisions. It will require a specific infrastructure to perform optimally, and it would require some equipment on the road. There is a strong link in this work with the cyber security and the data privacy, of course. On the digital mapping, you have need of the network navigation to share the road hierarchy and broadcast the network's update to other stakeholders, and to share in advance the real-time traffic management plan on the circulation plan on the web, and to be it's could be used to the current situation of the automated driving. You need also to as road operators, road network, to help the vehicle positioning. So the road to have a road reasonably free of obstacles, and to help the positioning, to have a continuity and the consistency of some reference points. So it's need to have a policy, maintenance of a policy, and you need to process to share the information about the road, about the environment, about the installations of the equipment. In terms of connectivity, it's a big part. but it's not the connectivities. It's mandatory, I will say, for the automated driving, but it's not really specific to the automated driving system, because the CITS for the human drivers is quite sufficient in most cases. In most use cases, it's for the automated driving. It's related to the let's say the hero reasons of the vehicles, but some use cases, but could also need additional ad hoc connectivities. Of course, not CITS. For example, for the platooning, you can have a LiFi, which is a Wi-Fi based on the light. So it's specific for some use cases, but in many of the use cases, you can use the let's say the traditional CITS. But you in part of the road operators, we will need a diagnosis to implement the CITS on specific road sections, on to make it with a good fidelity for the automated driving. So the network operators should adhere to European and international standards or guidelines in order to be sure that we had cross-border interoperability. In terms of national activities, there is a lot, so we cannot make put it on a screen. All it's done in this time. We separate technical and organizational group. For example, some group in UK, the Center for Connected and Automated Vehicles. We have also group on some different group like Roundtable in Germany, or some association, for example, in Spain. A big part of work for the harmonization is met by the standardization group. So you have standardization group in ISO TC 204 related to the ADAS vehicle roadway warning and control system. You have also, of course, in the TC 22 the vehicle TC 204 is for the ITS, and TC 22 is for the vehicle. You have the TC 22 acting on data communications. You also at the same parts, the same kind of group dealing with cooperative ITS on the specific group now in the same part dealing with the road interaction between the ADAS and the autonomous vehicle. You also have a national strategy. For example, in France, Germany, Finland, and Spain, strategy was already shown to the public. In France, we just have a redefinition of the strategic now on the this strategy taking into account some recommends towards the digital infrastructures and recommends towards the legal and regulational frameworks. You have also some action initiative which help to develop the automated driving. So you have the call for project. For example, in France, the EUEIP call for the experimentation of the automated mobility, and in Spain, for example, on the deployment of the 5G technologies. So to conclude, specifically on the recommends towards the road networks operators, you will need to have consistency and continuity within the networks, but also between the networks. Without too much local particularity, so it could be good to avoid this on the maintenance process, in order to know the quality of the infrastructures. On parts of the digital infrastructures, of course, it will need to invest a little bit in this, but to share the data. But it's on the way to the new infrastructures, on the new technology for the management of the road. On the maintenance on networks management process, you will have to set up assessment management on the maintenance process to ensure good sign on marking visibilities and to ensure that we know the quality of the roadside. For the road classification, it will be a work to do to have an extensive inventory on the classification of the road networks. So thank you. Perhaps you have some additional questions.
Thank you, Ludovic. Actually, we have one question from audience already now. Mr. Risto Kulmala, would you mind?
Sorry, I cannot.
Risto, please, can you present your question you wrote in the chat box?
Okay, I see the question of the chat box. As the automated vehicle
okay. Okay, I can read it if Risto is not able to open his mic. He writes, as the automated vehicle ecosystem continuously evolves, the requirements also change in time. How often should documents like yours be updated?
Yes, of course. These documents need to be updated because we made the works on it was finished on June 2020 on basis of document we collect during the project. So I cannot say perhaps it's a 1 year update which is needed because the works evolve a lot and we need to organize this update. It should be a follow up of our works for the two task. It could be, I think, achieved in the link or with the CCIM partnerships, as we have a presentation just before. Yes, we need this update, of course, because since we write the document, some national strategy was redefined, like in France, on the new project appears more and more.
Okay, thank you. By myself, I would have one question when I was reading your slides beforehand. Yeah. It seems that deployment of automated vehicles will ask a lot in terms of investment and maintenance by the road operators. Would it be possible in practice?
Yes, the investments could afraid road operator, but it's not necessarily a specific investment because the CITS are in deployment for the human driver, and there is no extra cost for the automated vehicles. By the way, the project running in this time, like the L3 pilot in Europe, SAM in France, security on the acceptability of the automated mobility, or over national pilot projects, will give some common goods on the real needs towards the infrastructure by the car manufacturers. On the other ones, you have a lot of work is done in the standardization to minimize the cost impact by preparing new generations of adapted road equipment, of course. For example, in the CEN TC226 Working Group 12, which focused on the road acceleration for automated vehicles on ADAS, the support to evolve existing standard by the integration of the automated vehicle capabilities. But in exchange with the car manufacturers, there was some discussion to understand the capability of the road on the limit in the ODD that can offer the road, in order to focus for the car manufacturers on the technical challenge that the automated vehicle has to achieve, to focus on. Finally, for the road operators and road authority, automated vehicles, it can be seen as a challenge, but also as opportunities. The World Road Association PIAC conclude on this on a report on the same way as of our tax one works. So I don't know the cost of the investment, but it's a beginning now of concrete works, and we will do it in a learn by doing way.
Thank you. Here's one question in the chat box. Mr. Gilberto Tognoni asks, how much CITS-wide implementation is essential for the automated driving development?
It depends of the level of automated driving we want to offer on the road networks. If you want, of course, level 4, the ODD is higher, and you will need a better ITS deployment to be on the required let's say infrastructure ODD. So that depend of the services the road user want to offer to make the automated driving available.
Okay, thank you, Ludovic, for a nice presentation. Next one, we have Magnus Hjelmdahl from Sweden. He's a senior consultant and group manager at the ITS and traffic system group at Sweco. He got his PhD in 2004 in traffic technology and has since then worked with ITS, driver support systems, and connected and automated mobility. Magnus, please.
So, I will talk about the impacts of cost and benefits of highly automated driving and work we did within EUEIP 4.2. And my name, as Anna said, is Magnus Hjelmdahl, and I would also like to mention my colleague Visual Bade here from Sweco, who's done a lot of the work in terms of editing and collecting literature and so on. This work was carried out in EUEIP Activity 4.2, which aims to dig up knowledge and support for decisions for road operators and help them take correct and informed decisions on how to facilitate automated driving and also automating their own core business. And then this specific work was done within task 2 there, which is about the impacts and the economic feasibility of automated driving, and also looking at those questions from a relevance point from road authorities and road operators. This presentation will be divided into a short discussion on the methodology we used, some presentation of the impacts, the benefits, and the costs we discovered within this work, and then finally some recommendations based on this. So, starting with the methodology. We used existing literature in this review to find what was information we could, but we also did a large inventory of ongoing studies using the vast network within EUEIP to find not just the published papers, but also reports in various countries, national languages, and so on, to see what kind of information was able to dig up. And after this first review of literature and making an assessment of that and trying to structure it, we took those results to a workshop, which we had in Torino in 2019 with a number of experts, a public workshop, and then to further define the scope for automated system. And at that workshop, we focused on level 4 and some level 3 plus systems. And the use cases we looked at was automated shuttles, highway pilot, robotaxis, automated valet parking, and truck platooning. And then after the workshop and the results we got from that, we used a multi-criteria decision analysis as a tool to define the various impacts and costs and try to value them against each other. So, looking at some of the impacts we've discovered. After the workshop, we were able to compile these impacts in these different categories. And of course, there's different ways you can slice this cake, but this was one that fit the data that we had. And interesting, but maybe not so surprising, different studies, of course, had different, maybe sometimes contradicting results for these cases. And that, of course, could be on various reasons based on the study, but also based on the level of connectivity and automation that was looked at or assumed in that study. But if I go through some of these, I'm not going to go through them all, but you can read more about them in the report, which is on the EUEIP website. Looking at mobility, it's believed that automated vehicles could increase car sharing. Vehicles will be used more efficiently, which would be good in terms of mobility. On the other hand, we expect increased kilometers traveled due to increased accessibility and increased travel comfort, etc. So different results there. Traffic safety in general, not so much contradiction here. It is believed that traffic safety will be improved. Then, of course, depending on the adoption of this automated system has an effect on how large that effect is. Capacity in traffic flow is also believed to be improved. A smoother traffic flow and also shorter headways and connectivity between vehicles could improve the capacity in traffic flow. If we look at public transport, for example, as well, some studies have shown that this will become less attractive because of more privately owned vehicles that will then compete with public transport, while others say that automated vehicles can be seen as a good complement to conventional public transport. And of course, it's all depending on how you actually deploy and implement the automated systems and what kind of restrictions you put on them, for instance. Impacts on physical infrastructure, higher maintenance costs can be expected, especially depending on what ODD you have in this for the system. Also digital infrastructure, higher requirement for digital infrastructure, of course, for instance, precise geolocation, HD maps, connectivity, etc. Cybersecurity is, of course, something as well where we expect big impact that needs to be handled since these vehicles use connectivity. Looking at the benefits, again, subject to level of connectivity and automation and also rate of adoption of these systems, of course. The benefits are usually higher the more higher connectivity, higher level of automation you have. But for instance, congestion mitigation, expect that the automated driving will free up space on the road. At an early stage of the implementation phase, automated vehicles may actually increase congestion with various driving behavior compared to conventional vehicles, for instance. But again, with more and more connectivity, improved sensing, and maybe dedicated policies, also congestion could or should reduce. Traffic safety is, of course, the most anticipated benefit. It is expected that these vehicles will be safer and behave better than human drivers. And increase road capacity and reduce costs as well. More efficient vehicle traffic may reduce congestion than roadway costs. Looking at some of the costs, we categorize costs in these 4 groups: societal, capital, operations level, and maintenance. Societal is about risks and traffic problems, social equity concerns, and so on. Capital cost is about the vehicle and the infrastructure and purchase of equipment. Operating costs in terms of deploying system and operating costs for digital and physical infrastructure. And then, of course, maintenance cost is one cost as well. It's important. The largest costs, that was found was the provision of safe harbors in case that the vehicles need to stop or the ODD does not actually work anymore. Signs and barriers for access control, adaptation of traffic centers and systems, up-to-date HD maps, trunk communication with fiber optics cabling, and game fences alongside roads. These were some of the costs that were identified in this that stood out as significant. It is very, very difficult to define the exact costs because there aren't really any large-scale studies showing this. There aren't any clear criteria or specifications from, for instance, the vehicle manufacturers on what do they actually need. So there's a lot of uncertainty regarding the costs. There's also a large uncertainty, maybe the biggest discussion at this stage, how these costs will be divided between different stakeholders. It's of course interesting that the stakeholders that has the highest benefits also take the highest costs. So that's a discussion in the future. The recommendations from this study is several recommendations, but 4 main ones. One is the need to launch pilots. We need to have more research and more coordination with empirical pilots, looking at both infrastructure, technical, and societal focus to better understand cost and benefits. There's a lot of focus on deployment and what is the correct way to do deployment. And that's of course good, but I think we also need to allow ourselves to trial and error a bit, because it's better to error now on a pilot scale than error when we take the big decisions. We talked about the dependency on how we actually deploy this system, that the cost and benefits will vary, for instance, for public transport. So it's important to take this into the planning stage. How can we plan our societies? How can we plan traffic? How can we plan new areas and everything linked around this to actually make sure that we reap the benefits of automated vehicles and try not to get so much of the disbenefits. And this, I think planning is something that need to take a more active role in this area. There's of course a need for new business models. We see high costs, especially in the initial phase. Benefits may become at a later stage, and the cost might not be at the same stakeholder as the one reaping the benefits. And then of course all this is data driven, so there is a need to come up with business models, technologies, and ways of share data and trust between stakeholders, for instance, on how actually to share data. And this is not only for automated driving, of course, but also for other connected services. But everything here is data driven, so there's a big need to take a further step in terms of that. And that was the recommendations from this study and all I had to present. Thank you.
Thank you, Magnus. Interesting. How do you see, what is their next step? Well, what comes after this?
I think that we need, as I said from the study here, more pilots and more research, and try to scale up. And I think also that road operators, cities, and also OEMs need to, first of all, find ways to collaborate, because no one can do this by their own. Road operators can't introduce this, OEMs can't introduce this. We need the service providers and so on. So we need to find ways to cooperate. And then I would recommend start testing, of course, in a safe way and a controlled way, but see what can be done. What are the benefits? It's difficult to say exactly this is the way we should deploy it. So we need to know more, and there probably isn't just one way to do it. There could be one way for public transport in a certain area and one way for smaller cities outside bigger cities that could have a different thinking. So we need to get more knowledge about this. So cooperation and pilots and testing, that's the way forward.
So as you said, that so many stakeholders are involved, so many authorities, so many, like any kind of organizations are involved in the whole society. Who should then take lead of this? Who should coordinate all these evaluation actions, and how this should be financed?
That's a big question. There's a lot of we know there's a lot of research and money involved in actually developing the technologies from even new players like OEMs, of course, but then Waymo and Baidu and other tech giants that are looking into this. I think it would be interesting or good if I don't think that the road operators on site should necessarily take the lead in implementing this, but I think could take a more active role in actually doing the research and figuring out how should we use this vehicle the best way, how should we do this to get the best societal benefits. And to be able to do that, I think that we need to have some kind of societal lead, or if that means that they need to put in all the money, or if there are other ways to do it, I don't want to, could be discussed, of course, but an active participation, at least from society, to make sure that we actually get the societal benefits and the citizen perspective in a good way in this.
So do you mean authorities by societal?
Authorities, road operators, EU, cities as well, I would say. I think it would be, we cannot only let OEMs and tech providers draw the map here. Society should have a say as well.
Okay. Here's one question from the audience. It says here, the changes in mobility patterns may dominate the impacts. If, for example, self-driving private cars increase car use considerably, this can lead to major problems. You mentioned planning as a means to affect this development. How should we change planning practices, in your opinion?
I mean, one problem here in terms of planning is that planning is a slow process and has a horizon of 50 years or maybe more sometimes. Technology development has a horizon next quarter, which is a problem. We have had some, not within this EUEIP, but in some other projects together with cities and municipalities looking at planning. And I think one of the things we found is that if you start planning for not specifically automated vehicle, but start planning for what kind of society you want, you end up with a plan that allows for flexibility and to share bicycling, public transport, and cars, and finding that mix. And then how much of that is technology? I think the importance here for planning is to be more driven by a goal than a prognosis. What is it we want to achieve rather than what do we expect will happen? I think that, at least in Sweden, I think a lot of planning is based on a prognosis of what will happen. How much cars will we have in 10 years? How many people will live here? How will we travel in 10 years? How will we travel in 20 years? Focus instead of how do we want this society to be, and see how can we adapt and what kind of technologies can we use to achieve this. And then, of course, try to keep the flexibility there, because the technologies we plan for today is not the same as the technologies we have in 10 years. So, but that's a tricky question. It's not easy to change planning because it's a slow process and it's an old process in many ways.
Okay. Gert, you had a comment to the question.
Yes, thank you, Anna. I just wanted to say that I could not agree more with Magnus, with everything he said. So, first of all, yes, this is a field where we can only make progress if everybody gets involved, and that includes a very strong component of the infrastructure and the authorities at every single level. So cities, regions, member states, and the EU level. And it is so important not only to make it happen, but to indeed get the mobility that we want. So not develop technology for the sake of it and see what happens, but develop the technology only in a manner that it really improves mobility, to make it smarter, make it more sustainable. And that is precisely the goal and the objective behind the new EU partnership that we're setting up. So for the next 7 years, we will bring this entire community together to jointly develop the research that we need to reach our objectives. And again, this is something Magnus said, we need to, the core of this, there's of course many activities that are needed to make it happen, but the core is these demonstration activities, which are not just technical demonstrators, but showing how these vehicles can deliver real and better, more sustainable mobility. And of course, the whole idea behind such a partnership is also that these not become isolated demonstration projects, but that they are linked together, that they share, that they learn from each other, that we see what works, what doesn't work, and how we can repeat what works across Europe. So just to say that I fully agree, and I think that this is indeed what we're trying to achieve with the new partnership. Thank you.
So exciting
Thank
things
you,
ahead
Gert.
then.
Exactly. But now the time is running, and we need to step to the next speaker, who is Mihail Niculescu from Romania. He graduated from Polytechnic University of Bucharest from Faculty of Transport with an engineering...
Sorry, Anna, I think I'm first. Sorry.
Sorry. Okay. Sorry, I had this in wrong order. Okay, next one.
Doesn't matter.
We have Martin Amelink from the Netherlands. Yeah. Martin is a senior advisor, smart mobility at the Dutch Ministry of Transport and at Rijkswaterstaat, which is Dutch National Road Authority. Apart from EUEIP, he is currently doing research into the sustainability of Dutch roads from smart vehicles and developing and monitoring dashboard for smart mobility development. Martin has been active in the smart mobility domain since 2010. So thanks for Martin interrupting me, and please.
Yeah, thank you, Anna. Sorry for interrupting you, but just keeping the order we discussed. Thank you. Thank you also to the previous speakers for task 1 and 2. In task 3, we really built on the work also done there. So you'll probably recognize some of the elements that were presented there also in my story. So, but that's deliberate in that sense. And task 3 is really about making a roadmap for automated driving for road authorities. And I would like to tell you about the process of this roadmap and also, of course, about content. So I'll start the introduction of the work we did, and then, like I said, process and contents. And it's really about making a roadmap, including an action plan. So it's a look to the future and what actions could be taken, and on what in what time period these actions should be taken for especially road operators to facilitate automated driving on the road network. And we say here that 10 road networks are really the more focused on the highways. And the way we approached this task is that we first, let me introduce it. One of the most prominent developments, of course, is the automation of road transport in mobility. And of course, all the stakeholders in mobility need to consider their position for this topic. So, what is their vision? What is their desired direction of the development? What is each stakeholder's interests? What options and power do they have to steer the developments? And what can and should they practically do to prepare? And all stakeholders in mobility need to think about this. What does automation mean for me? What are the chances? What are the possible benefits? But also, what are the possible risks? And in this work, we look at the road authority perspective. What impact does automation have for them? But of course, consultation of other stakeholders like OEMs, like the EU, like other governments, was part of the work for this document. And I'd also like to say that this roadmap is part of a continuous effort in several initiatives. I can mention, of course, the CCAM platform. I can also mention projects like Mantra and projects like Inframix, which also really work on a roadmap and especially also the infrastructure part. They also project into the future what could be the best way to approach things. And we really try to align also with them and to have some common views. And also we see each other that we are part of the same efforts, and that this roadmap is of course not one thing we do and it's ended. We need to keep developing our vision, to keep track of the development, to really adjust our policies towards the technical developments that are happening. So the final result of our work is another step in an ongoing process. So that's what I would like to say. Regarding the process, we started with an open workshop in 2017, which mainly with road authorities themselves. And this led to an initial roadmap to kick off the work and to continue from that. Then in 2018 and 2019, we had open workshops more connecting to other stakeholders. In 2018, we really had an open workshop with the L3 pilot project, which is mostly a lot of OEMs participating in that. So it was a really valuable way to exchange views and to see what's happening on both sides in both projects, and how we can better align that and learn from each other. In the 2019 workshop, really focused on ODD, so the circumstances for which a car is made to drive automatically, which circumstances does it need. And like mentioned also in task 1, we really discussed about how can we describe the circumstances in an aligned way, that we understand each other. What do we mean by certain elements? How does the infrastructure should look like? That we, like I said, that we can understand each other. And you see the kind of tables we developed there. And this was also input also for the CCAM platform and also for Mantra. So we really helped each other, and hopefully we increased the mutual understanding between several stakeholders. So this year we came to an immediate roadmap version for consultation. So following the open workshop, we also had national consultation. So the representatives of the EUEIP went to the experts in their own country to discuss the roadmap and the actions we mentioned there, to get really national feedback. So to further strengthen the actions, and also that people can really have a good feeling for that. Apart from these national consultations, we liaisoned with others like CCAM, the CEDAR CAT group, and also we had an event at Frill with several projects presenting their roadmaps. We had a final event at the end of September. We really presented the roadmap, but also had a really interactive discussion with where people can really give their position on the different actions we have, and to provoke also discussion among them to really get them thinking. And recently we finalized our roadmap. So about the content of the roadmap, of course, and so far it's mostly a process in this presentation, of course. So the writing team consisted of Finland and the Netherlands, and other countries in the project contributed. And we have two main topics. So the physical and digital infrastructure with a focus on ODD, and the other thing was the cost and benefits. So this really linked also to task 2 work, and then more a roadmap kind of approach to the work that was done there. And in chapter 4, we had analysis of European and national policies, and in chapter 5 was the actual roadmap. We started an overview of existing other work, so to really explain how it connects, our work connects to them, and with a list of actions and recommendations. I encourage you to check the document on the website to see all the details about this. And we came to 45 actions and recommendations, which I won't go into all, of course, in terms of this presentation. But we divided them into several subtopics. So one of it was about data provision. One of them was about harmonization. How can we really align our efforts in a harmonized way? What are possible investments for road authorities? What's our topics for more research? How can we optimize the process of our organizations? And what are costs and benefits? So there were actions and recommendations for all of these subtopics, and I would like to highlight some of them. So the first one here is to consider more consistency in road network and less particularities. So this really connects to the item that, for instance, in the Netherlands, there are specific road sections that have a specific layout, especially on on-ramps. And we're not saying at the moment, well, you should get rid of them, because that's not really what we're saying. But we need to consider what would be the best way if we start redesigning the road, or there's big roadworks. Can we look at more consistency with other countries, or at least within the own network? Because that makes it easier for OEMs to develop their systems, because they know what to expect in the several countries. So we really need to think about more consistency in that sense. The second one here is we need to prepare to invest to support the ODD. Because if we could look at the infrastructure to introduce certain elements that helps OEMs to drive automatically, to expand the OTD, as they say. But of course, we also need to be quite selective, because you could look at the current sensors of the cars, what they can do at the moment, and then we can say, well, they can do this and this, but we need to help them with certain infrastructure investments. But on the other hand, sensors also develop very quickly, and nobody's sure how good they will be in a couple of years. So if you start investing now, but in a couple of years the sensors are much better, so you may have done some investment which is not really necessary in the end. So that's really something that's really the conversation is with OEMs is very important, also with others, and you need to prepare, but also to be very selective. The third one here is about minimal risk maneuvers. So if someone is driving automatically, or if a car is driving automatically, at some point maybe it has to hand over to the driver again, because it's not at some point it's not possible to drive automatically anymore. And there's a risk that the driver doesn't take over because he's not fit to do so, or he's asleep or something. Then there will be a minimal risk maneuver. The car has to do something, and there's several possibilities for doing this. But as road authority, you need to think about it. What are the OEMs doing in terms of minimal risk maneuvers, and what can we do as authorities to prepare for that? Maybe we can look at certain parking places along the highway that they can park their car there, if that is a good solution. But this is something we need to think about as road authorities, but also really also in combination with the OEMs and in conversation with them. And the last one is also mentioned by Magnus already. Make those pilots and really include also the societal focus and get better understanding of cost and benefits, and to be part of the project management, the project setup, so that you, if you start with that from scratch in a project, then you can get the best effects. And you shouldn't forget this part of the project to really get the cost and benefits good into the picture. So getting to the conclusions of the roadmap. So, like I said, it's premature to commence deployments unless road authorities and operators are certain that the solutions invested in will not become obsolete in the short term, because, for instance, the sensors are becoming much better. So we really need to think about that. There's the importance of research, trials, and pilots, and combined with a structured dialogue with all the industry partners. There are some no regret actions. Some things like data provision from authorities are also beneficial to current human operated vehicles. So and they're also beneficial for automated vehicles. So those things you should really identify and work on. And timing, well, some actions may seem long into the future, but you may need to start on the short term with the thinking, because planning takes usually a long time. So you need to think about it already now. And in general, the goals are to be prepared for automated driving as road authority, have influence on the developments, so the road network operation improves. And that automation is not happening to you, but you really have also some influence in it. You need to avoid excessive investment in vain, and the potential benefits you want to have them as soon as possible. And my last slide, well, the work in this roadmap needs to be taken further by project, but also road authorities themselves. It's an intermediate step, these actions that we defined here, and work has to continue. And not just on it's both research and deployment. They should go hand in hand. So we should focus both on the Horizon Europe part of European funding, but also the CEF funding. Both sides are very important to continue the work we defined in this roadmap. And with that, I would like to conclude my presentation.
Thank you, Martin. How do you see from your side the same question what I have asked previously also from Magnus and Ludovic? How do you see this work continues? Should the roadmap be updated? When and by who?
Yeah, so what I'm saying, I think the individual stakeholders, I would like that the individual stakeholders take up these actions and recommendations we put here and take them further in their national project, for instance, but also in European projects. And of course, if EUEIP would have a successor project, we can also update this roadmap, for instance, every 2 years. That would be a good time frame, I guess, because the developments are going really fast, and the results of the conversations we have with OEMs and other industry partners could really be part also in the update of this roadmap. It's not just EUEIP itself, but also really at the stakeholders and projects, the other ones. They should really also integrate them.
Okay, then I have a comment from the audience. This is actually both for Magnus and Martin. I would like to have from you a really short comment because we are running out of time. So Mihai will also have enough time. But this says that this morning, Charles Michel and Ursula von der Leyen announced, we decided to cut our greenhouse gas emissions of at least 55% by 2030. Do you imagine that the decision of today will have an impact on national policies that you collected and studied?
Yeah, that's a good question, of course. I'm just thinking how to connect this to the work here. Of course, automation and smart mobility in general, I would say, have multiple goals, throughput and road safety, but also sustainability. And maybe sometimes the focus is a bit more on road safety and throughput with this kind of work. But of course, there's also a good link with sustainability and also with electrification, because that's also something that's really often linked to automation. So I think we can give more attention also to that topic. And this was already clear for organization, I guess, but it's really confirmed by the statement of this morning. Yeah.
Do you want Magnus to comment really shortly? You're muted.
And unmute.
Now you are muted.
No, I also read in the paper this morning that greenhouse gases in Sweden was reduced 10% during 2020 due to Corona, which is, of course, the main reason was that the transport had reduced. So that decision will affect. Transport is a big factor in cutting greenhouse gases, so it will have an effect. I think electrification is, of course, one big part in reducing greenhouse gases, but it's not the only solution. And I think it's crucial that the topics that we are discussing on automation has not a negative impact in terms of increased transport, for instance, that we use this technology to actually make things smarter. And I think maybe that focus very much has been in terms of safety and capacity on automation, and maybe we should have a bit higher focus on what we can do in terms of sustainability and cutting greenhouse gases. I think we could focus more on how to use this technology to increase or achieve that. So it should have an effect.
Okay, thank you. I would have here one more question from audience about standardization, but let's have Mihai to step on the floor first, and let's see at the end whether we have time for this additional question or not. So as I started already like 15 minutes ago, Mihai Niculescu is from Romania and graduated from Polytechnic University of Bucharest at Faculty of Transport with an engineering diploma in electronics and telematics. He also holds a PhD in transport and has more than 10 years of experience in ITS. Mihai has been involved in European and national projects related to ITS for road, rail and inland water waste transport, and is a member of several European expert groups. He is currently General Director of ITS Romania and serving the network of national ITS associations as Vice Chairman. Mihai, please.
Okay, thank you very much, Anna, for the introduction, and good morning, everybody. I will tell you a few things about our activities regarding the automation of road transport own ITS. So I think this fits well with the previous presentations, as Martin already started the discussion on the view from the road operator in terms of the impact of automated driving. So what we did in our activity is to focus on this specific topic of how automating their own processes will support this and other developments. So actually the specific objectives that we looked into in terms of automating road operators management centers was to identify the requirements. Then we look at identifying practices and lessons learned from different implementations. And of course, we also wanted to analyze and have an idea about what would be an optimal automation level for the operations and the services. And if you would like to know more about the results of our activities, I would encourage you to go on the website of EUEIP, and there you will find our deliverables, but also some information and conclusions from the workshops that we had and that we organized. Now, we are talking about automation, but on our task, we also focused on something a bit more specific, and what it is called autonomic systems. This probably is not a term that everybody is used to. It's something that comes mainly from computer science. And it is about actually having within the system some kind of so-called self functions, so that the system can actually on its own, for example, self-assess or self-manage in the operation. So the ideal is that the operator has only to set some goals for the system, and the system will manage itself in order to reach those goals. This is a different kind of automation, which we think can help even more the road operators to do their operations and to provide the services with the requirements of automated vehicles and all the data provision requirements. So going into details, we looked at automated and autonomic characteristics, and we selected some functions in terms of being an autonomic system. And as you can see, we separated them in two main categories. One are the high-level ones, which are implemented for, let's say, the entire system. And the supporting functions are the ones that are actually helping the high-level ones to be implemented and to provide the necessary behavior of the system. So in terms to be able to self-heal itself. For example, a system needs to be able to self-diagnose also. Or if we want to have some kind of self-management of the system, it also needs to learn by itself. So it needs to be supported by self-learning in order to have this high-level behavior. But of course, we need to consider how these are implemented, and also from the perspective of what the Traffic Management Center is doing. So actually, we considered how this automation should be planned, and how the authorities and the operators should consider these things. So what we did, we looked at the existing TMCs, and we also discussed with our group and with our experts, and we selected these functions. Probably in the slide, not all of them are visible, but you can check them in our deliverables. So these are the common functions of a TMC that we propose is the most beneficial to be automated in order to improve the operators and to help with the services that they need to provide. So to give an example, we have here information on planned events, or we have ramp management. So these are the kind of functions that we saw will really benefit from an automation and from providing support to the traffic management operator in his decision. But of course, when we plan the automation and when we have some functions that we want to automate, we also need to consider how to do this and in what way. So for this idea, we considered and we thought about developing some automation scales in order to support the idea of introducing the automation and having this kind of stepwise approach for this. And we thought it's beneficial to look from two perspectives. One, from the point of view of the actual automation of the systems, the hardware, and the other perspective was how actually the automation helps for the operator and how it is seen from their point of view. So we came up with these scales. On the left side, we have from the system, and it is somehow a gradual increase of the automation, starting with the A0 level, where we have just some modules in the hardware that are automated, but not much more than that. And then we go all the way to A4, where the entire systems as a whole have this, what I mentioned, autonomic properties. So they have these capabilities of self-healing, self-configuration, and so on. Looking then from the operator perspective, Again, our scales are an increase of automation starting from 0, which basically means that from the operator perspective, he or she has to make all the decision. The system just displays the information and nothing more. And then we go higher until the level 5. This would mean that the operator trusts the systems to make all the decisions in all the situations. So in this very high level, in almost all the situations, the operator doesn't have to intervene in any kind of functions that the TMC is providing. And of course, this correlates with the view from hardware point of perspective, because it is assumed that in order to have this high level 5, you would also need a system that is fully autonomic in order to provide this kind of support for the operator. So, of course, this is useful, but to implement these things and to actually have some feedback on the benefits that you can get, it is always useful to have some way of assessing the benefits of your automation. And for that, we proposed some KPIs that can support this assessment and can support having an evaluation of how much the automation has actually helped your system. And we have two categories. We have some deployment KPIs, so looking more on what's implemented in the system, like for example the number of the percentage of hardware modules that have automated alarms. But again, we are also looking from the operational point of view, so we have the operational KPIs, and for example a percentage of automatically detected incidents as compared to the ones that are detected by the human operators. So we define and we propose this kind of KPIs in order to support the implementation of the automation and to make it easier to assess it. And this is our goal in the end, to have as much automation as possible for the TMCs. And we also considered and thought about an action plan for how this automation can happen, taking as a time horizon in line with other roadmaps within Activity 4.2, but also in other projects. So we took 2030 as our view, and of course there is a need for research on automated and autonomous functions, as it was mentioned before. Also for the other activities, piloting is very important, and of course really connected with automated driving. And for the entire period, we see the need to install these autonomic and automated functions in upgrades of the systems, but also to start the implementation even from 21, 22, the implementation of self-management functions in ITS systems. So this is our idea and our proposal how the automation can evolve, the automation of road operator can evolve over the years. Now to somehow conclude what I tried to tell you about our activities, we already saw that there are experiences with the automation and TMCs, and we saw there were clear benefits. We actually looked at the existing systems in the participating countries in our in EUEIP, and we did a judgment on which of the scales we can find in those systems. We realized that there are some functions, for example, traffic management, which are very high on the automation, while the others are quite low on this scale. So it shows that not all the function, and it's not always necessary for all the functions to be automated. And on the other hand, there is also room for improvement in some areas. We also have these KPIs, which we think are beneficial, together with some targets that we estimated. Of course, this will need to be revisited, let's say, in the future, and maybe take into account the new developments. And we also proposed this action plan for going further with the TMC automation, always in close cooperation with the vehicle manufacturers. Okay, thank you. This was what I wanted to tell you about our activities.
Okay, thank you, Mihai. We are now running already overtime. We are allowed to take a couple of more minutes overtime if we want. 10 people I see have already left, but we still have 69 online. Here is a comment on data. Or question like saying, would you comment on the data, the amount and quality of data required to have appropriate and sufficient feedback for the self-learning, self-optimizing of TMC operations, etc.?
Yes, thank you for that question. It's a very good issue. I agree, we need to have very good quality data, and we also need to have some kind of quality management system in order to, let's say, select the data and also look at where we are with the quality and how can it be improved. So yes, I agree that the quality is very relevant to get to these levels of automation.
Okay. Then here's a question saying, can we call it AI application?
It's, well, what we looked at is somehow part of AI in some aspects. But I think it's not entirely only AI in the way that it is used today. So it has learning, yes, but to some extent, it also needs some extra components, not only, let's say, this AI implementation.
Okay, then I have here a comment and question for maybe for all of you, saying several comments and dependencies are focused on the costs linked to the automated vehicles introduction. One main dependency is on the cost for the final user, the cost of the vehicle itself, and of the services needed. Unless a reasonable estimate of those costs is available, it is impossible to understand when the automated vehicles will have a market breakthrough. Can the road operators invest the needed resources without a reference reliable time horizon on when the vehicles will actually be on the roads?
I think if I should start, I think this is where all the cooperation we mentioned comes in, because you need to take this stepwise, and you need to take them stepwise together as well. And there are big investment costs in the beginning, benefits might come a bit later. And I think it will be impossible to come up with an accurate enough cost. You need to have indications, a target that this is what you want to achieve, and how you want to progress towards that target. To come up with a sum that this is how much it's going to cost, and this is how you're going to do it, and then go ahead is impossible. You have to do it stepwise together and work together. So it's difficult to work with just an estimated cost and then decide on who takes the investments.
Does somebody else want to give comment?
Yeah, maybe I can say. I think the question also involved the question, the cost for the end user. I think it was part of it. So
yes.
So yeah, it of course also depends what business model is behind that, because many say that it's not a case of people buying an actual automated vehicle, but also it could be a service model that you have, like a subscription. So it's of course that also depends on that setup, what the cost for the end user will be and how attractive it will be for the end user.
Okay, let me see here, something else. No. Then there was a question whether these presentations will be published, and yes, they will be, as well as the whole webinar at the EUEIP website. Now that we are running out of time, or we did it already, I would really much thank to our audience who was listening to this. I would like to thank our speakers for the excellent presentations, and I would like to give thanks to the whole EUEIP 4.2 activity and persons working on that, especially to my right hand here, Mr. Risto Kulmala, who has really done an excellent job when running through the whole activity and making it to end by the end of this year as it was planned. So with these words, I would like to end this webinar and wish you all a nice vacation time and keep safe. Bye-bye.
Thank you, Anna. Thank you.
Thank you.